Measuring refractive index. To measure the refractive index of a material, such as this glass block, we could have an arrangement something like this, with a ray box sending a ray of light towards the flat face of the glass block at the centre of this face, where we have a normal, a line at 90 degrees to this face. This is our angle of incidence, this our angle of refraction. What we need to do is vary the angle of incidence from 0 to 90 degrees, and for each of these measure the angle of refraction. The refractive index in going from material 1 to material 2 is given this symbol and is calculated from the sine of the angle of incidence over the sine of the angle of refraction. We can rearrange this to give that the sine of the angle of refraction is equal to 1 over the refractive index times the sine of the angle of incidence. If we compare this with the standard equation of the straight line through the origin graph, y equals mx, we can have sine r as our y value, 1 over the refractive index as our gradient m, and sine I as our x value. So if we plot a graph of sine r against sine I, we should get a straight line through the origin, and its gradient will be 1 over the refractive index, or refractive index is equal to 1 over gradient. It's important to know the refractive index very accurately when making lenses. We plot the graph this way round, so the independent variable is on the x-axis, the dependent variable on the y-axis. It's very important to know the refractive index accurately when making lenses for spectacles. They must match the power needed to improve a person's eyesight very precisely.